Hello viewers, in this video you will completely learn about HPLC. HPLC is an abbreviation for High Performance Liquid Chromatography. Chromatography is a technique for separation. Chromatogram is the result of chromatography. And chromatograph is the instrument used to conduct chromatography. High Performance Liquid Chromatography, HPLC, is an analytical technique to separate, identify, and quantify components in a mixture. It is the main chromatography technique used in most laboratories worldwide. Principle of HPLC. The separation principle of HPLC is based on the distribution of the analyte, sample, between a mobile phase, eluent, and a stationary phase, packing material of the column. Depending on the chemical structure of the analyte, the molecules are retarded while passing the stationary phase. The specific intermolecular interactions between the molecules of a sample and the packing material define their time on column. Hence, different constituents of a sample are eluted at different times. Thereby, the separation of the sample ingredients is achieved. Apparatus. Specialized apparatus is required for an HPLC separation, because of the high pressures and low tolerances under which the separation occurs. Thus, HPLC equipment must be of high quality. It is therefore expensive. Solvent. The mobile phase, or solvent, in HPLC is usually a mixture of polar and non-polar liquid components, whose respective concentrations are varied depending on the composition of the sample. As the solvent is passed through a very narrow bore column, any contaminants could at worst plug the column, or at the very least add variability to the retention times during repeated different trials. Therefore, HPLC solvent must be kept free of dissolved gases, which could come out of solution mid-separation, and particulates. Column. In the HPLC column, the components of the sample separate based on their differing interactions with the column packing. If a species interacts more strongly with the stationary phase in the column, it will spend more time adsorbed to the column's adsorbent and will therefore have a greater retention time. Columns can be packed with solids such as silica or alumina. These columns are called homogeneous columns. If stationary phase in the column is a liquid, the column is deemed a bonded column. Bonded columns contain a liquid stationary phase bonded to a solid support, which is again usually silica or alumina. The value of the constant C described in the Van Demeter equation is proportional, in HPLC, to the diameter of the particles that constitute the column's packing material. Pump. The HPLC pump drives the solvent and sample through the column. To reduce variation in the elution, the pump must maintain a constant, pulse-free, flow rate. This is achieved with multi-piston pumps. The presence of two pistons allows the flow rate to be controlled by one piston as the other recharges. A syringe pump can be used for even greater control of flow rate. However, the syringe pump is unable to produce as much pressure as a piston pump, so it cannot be used in all HPLC applications. Detector. The HPLC detector, located at the end of the column, must register the presence of various components of the sample, but must not detect the solvent. For that reason, there is no universal detector that works for all separations. A common HPLC detector is a UV absorption detector, as most medium to large molecules absorb UV radiation. Detectors that measure fluorescence and refractive index are also used for special applications. A relatively new development is the combination of an HPLC separation with an NMR detector. This allows the pure components of the sample to be identified and quantified by nuclear magnetic resonance after having been separated by HPLC, in one integrated process. Types of HPLC. The two most common variants are normal phase and reversed phase HPLC. Normal phase HPLC. The column is filled with tiny silica particles, and a non-polar solvent, for example, hexane. A typical column has an internal diameter of 4.6 mm or smaller and a length of 150 to 250 mm. Non-polar compounds in the mixture will pass more quickly through the column, as polar compounds will stick longer to the polar silica than non-polar compounds will. Reversed phase HPLC. The column size is the same. The column is filled with silica particles which are modified to make them non-polar. This is done by attaching long hydrocarbon chains, 8-18C atoms, to its surface. A polar solvent is used, for example, a mixture of water and an alcohol such as methanol. Polar compounds in the mixture will pass more quickly through the column, because a strong attraction occurs between the polar solvent and the polar molecules in the mixture. Non-polar molecules are slowed down on their way through the column. They form varying degrees of attraction with the hydrocarbon groups, principally through van der Waals dispersion forces and hydrophobic interactions. They are also less soluble in the aqueous mobile phase components, facilitating their interactions with the hydrocarbon groups. Reversed phase HPLC is the most commonly used form of HPLC. What are different uses of HPLC? It has wide applications in areas such as pharmaceutical, bioanalytical, food and beverage, clinical, forensic, environmental and drug development laboratories. For example, in a medical setting, HPLC can be used to determine the contents and concentrations of substances in biological materials. This could include drug analysis of urine or detection of vitamin levels in blood serum. Thanks for watching. If you have any question, feel free to ask.